All right, hello, welcome back. So in this video, I'm going to cover the rate function, right? And the rate function basically helps us solve for the interest rate of a given either a lump sum payment or an annuity. And we're gonna deal with two lump sum payments and then two annuity problems. Um, and it's the rate function can be a bit tricky because sometimes you have to put in a guess. And I'll show you in a second. So let's start off with the first one. So suppose you have $1,430 in a savings account. If you leave the funds in the account for 24 years, what annual interest rate must you earn in order to have 55,000? Okay. So let's go to 1. We have equal sign. We'll just type in rate and then open parentheses. And of course, in 24 years, right? That's how long we're going to wait for. This is a lump sum problem because the $1,430 in savings is like there already, and it's going to be there for 24 years. There's no mention of additional payments, so payment's going to be 0. The present value is currently what you have in savings. So, and of course, because that's not accessed today, that has to go in as negative. So it's negative 1430. Okay, comma. Future value is the 55,000. And then the type, this is a lump sum problem, so the type doesn't matter, so we'll just put 0. And then the guess, usually when it comes to lump sum problems, you can just do like 1 divided by however long it's going to be. That's usually a good guess in regards to lump sum problems. When it comes to annuities, a different guess. But basically, most of the time, this rate function uses this iterative method. It doesn't use like an algebraic formulation, so it usually needs a starting point, and then it'll follow that. It uses either the bisection method or Newton-Raphson method, one of those two. You don't really need to know that. I guess I'm just showing off. All right, so close the parentheses and press enter, and you can see that in order for this $1,430 to turn into $55,000 in 24 years, you're going to need to earn a very high interest rate, 16.424%. That's probably not feasible anytime soon. So you might have to lower your projection or wait longer. Okay. All right, so now let's look at an annuity problem. So starting today, you plan to save $890 each year for 44 years when you retire. So we know that this is an annuity, right? Because $890 is going to be paid each year for 44 years. And because you're starting today, that means it's an annuity due. If you hope to have $210,400 by the time you retire, what annual interest rate must you earn in order to reach your goal? Okay, so we'll go equal sign, rate, open parentheses. Number of periods is 44, comma. The payment, since this is an outflow and going into a savings account, it has to be negative, so negative 890, comma. Present value, what we're there is no present value because it's an annuity. The first payment is essentially it is part of the annuity, so there's no present value. That first payment that you make today is already included in the payment, is basically what I was trying to say. So there's no present value. The future value, that's 210,000. That's what we hope to have by the time we retire. So 210,400, comma. Now this is an annuity due, so we'll put 1. And then the guess is, a good guess is usually to take the payment and divide it by whatever, either the future value or the present value. That's usually a good way to guess. So in this case, you can just do 890 divided by 210,400, right? You don't actually have to take the ratio and then put it in. You can actually just go ahead and do that math in there. That slash sign right here denotes a division sign, okay? And then we'll close parentheses, press enter, and we can see that we're going to need to earn a 6.375% interest rate in order to reach this goal within 44 years. That's a lot more reasonable than 16.424%, right? Okay, number 3. So a new retiree has $649,732.83 in savings. She expects to live another 29 years. If she hopes to withdraw $51,000 each year for her retirement each year of her retirement, starting next year. So this is an annuity. $51,000 is being withdrawn each year. All right, so that's a positive flow into her. And this is an annuity, and because the first withdrawal starts in a year, 1 year from today, that means it's an ordinary annuity. So what annual interest rate must she earn in order to have this sort of retirement? Okay, so we'll do equal sign rate once again, and in per is going to be 29. Payment, she's receiving 51,000. That's a cash inflow to her, so that's basically positive 51,000. Present value, so the new retiree, that's how much she has in savings right now. She doesn't have access to all these savings, so that means it's going to go in as negative. So for 649,000, negative 649, remember no comma with thousands, 32.83, and comma. And then, of course, by the time she retires, she's presumably not going to have anything left, so her future value is 0. The type, because the first withdrawal happens a year from today, that means it's an ordinary annuity, so we'll put 0 for type. And the guess, once again, we're going to divide the payment by, in this case, the present value. So 51,000 divided by 649,732.83. We'll close that, parentheses, and we can see that the retiree will need 6.6292%. She'll need to earn a 6.63% interest rate each year in order to have this kind of retirement, right? Okay, final one, a zero coupon bond. I'll talk more about this, but a zero coupon bond, it's like a government bond. It's a type of treasury. Most coupon bonds actually make a payment every 6 months if you buy one. But there are some bonds called zero coupon bonds whereby it'll pay a certain amount of money at the end of its maturity. Nothing in between, nothing beforehand. But the implied interest, so to speak, comes from an appreciation of the price. So the bond's price is always less than this $1,000 par. So where the interest comes from, it comes from the capital gain in the bond, right? The bond's price usually is going to rise in such a way that from each year, so that they actually have some sort of capital gain. But basically, the current price of this bond is $851.44, right? And I want you to calculate the zero coupon bond's yield to maturity. So basically, the implied interest rate that's earned each year, right? So you're going to buy this bond today for $851.44, and then in 9 years, you will receive from the government $1,000, right? And so we want to know what your effective interest rate that you're earning is. Okay, so let's see. Let's do equal sign rate. Now this is a lump sum payment because there's no payment. When we talk about bonds, this will get a little more complicated, but so far this is all we're going to look at for right now. All right, so the number of periods is 9, comma. The payment is 0 because it's a lump sum. The present value is the price you pay for the bond today, so that's negative 851.44. You're paying this, so it should be negative. Comma, you're going to receive $1,000 after 9 years from the government, so that's 1,000. Comma, it's a lump sum payment, so type doesn't matter here. And here we can just do 1 divided by 9 to see what our best kind of interest rate is. We'll close parentheses, and we'll see that you're effectively earning on this bond 1.83%, 803% interest each year. So as I said, this isn't going to be paid out as money, but it's going to come from a price appreciation. So basically by year 8, this price should rise by 1.803%. So if I do 1 plus the interest rate and multiply it by 851.44, right? That means if you buy this bond and then wait a year, the price of that bond should rise by about 866%. It should rise to $866.79, right? And then, of course, if you wait until the 7th year, then again it should rise. Then the price of this bond should rise again. Oops, did not mean to do it. Yes, to $882, and eventually it's going to get closer and closer to this $1,000, right? Uh, Usually people, I think, will just buy these bonds for. It's usually banks, not even individuals. Rarely, I mean, some individuals might, but they'll just buy these bonds. They might hold on to it for a year or two, and then they'll sell it. Right? They're kind of just trying to find a place to park their money. But that's how a zero coupon bond works. Right. A yield to maturity is basically an implied interest rate. Okay. So that'll do it for this video, and you'll hear from me again. All right.